Hello and welcome to a code kata training video. So I've created an account on Code Wars, and this is sort of because a friend of mine who's streaming, CJ at Coding Garden, has been doing some of these code kata videos, well, rather live streams where he's been doing these, and it sort of made me want to get into that a little bit too. So I don't have the time to do live streams as long as he does, but I figure I can create a few of these, and as I'm doing them, just put them up online. So this is a brand new account. No katas besides that first one to create an account have been completed. So I have an 8Q account, and so I guess let's just sort of get started and train. Okay, I have done a few of these in the past, but I never really got super into Code Wars. All right, so what are we doing here? Sum of two lowest possible integers. Create a function that returns the sum of the two lowest positive numbers given an array of minimum 4 integers. No floats or empty arrays will be passed. For example, when an array is passed like 19, 5, 42, 2, 77, the output should be 7 because 5 and 2 are 7, and those are the two small ones. And that should return that. And hint, do not modify the original array. And so we can see our test here looks like they don't include any of these. They just have their own ones. Okay, well, this should be fine. We have numbers as an array. We're going to put our code here. So I am using JavaScript. Oh, okay, we can't use the latest greatest yet. So we'll just use pure JavaScript 6.11. That's fine for me. Okay, so my idea here is we want to iterate through the array and just collect the top, the bottom two numbers. We could do a for loop, or we can do a reduce. Would probably be better for this because we're reducing it down to a single element, which is really just going to be an array of an array of two numbers, because that's all we want to do is just remove the other ones. Now, the other thing is we always know that we're going to get 4, right? Create a function that returns, given a minimum of 4 integers. We might get, like here, 1, 2, 3, 4. It could be significantly more. So I could also sort these. So I could sort them, but they do not want us to modify the original array, which is interesting because if I sort, this will get, if I run the sort method, this original array will get modified because that's what the sort method does. So let's try this. We'll do const, and we'll create a new array of like just the two numbers. So we'll call this toSmallest equals numbers dot reduce, and in reduce, well, we're going to take in the, well, sort of the iterator, so smallest, and we're going to take in like the current number. So I'll just call this number. I wonder if 611 has fat arrows and functions, or if I'm going to have to use a traditional function. We'll find out. So inside of here, I want to just compare. Is the current number smaller than both of these? So if it is, I want it to add it to smallest, and if it is not, I want to, well, to not. So I'm going to begin by not trying to do this one line right away. Okay, so I want to return a new array, and so I'm going to pass in an empty array just to make sure we start off with that. All right, so if the current number is not even in here at all, then, well, then it obviously has to be it is the smallest currently. So I can loop through here. I can do index of. I think I kind of have to loop through, don't I? So I do want to be able to break this in case it is smaller, because if it's a for each will unfortunately not allow me to break. It will go through everything. So I'm going to do a standard for loop. Let I equals 0. I is less than smallest dot length I plus plus. Okay, so now that we're in here, we want to compare, is the current number less than, or rather greater than or equal to these current ones? Because if it reaches the end, well, I guess I could say if it's smaller than any of them, I can just replace that one, can't I? Because if we go through here and we think the first one is going to be a 5, so I'm going to add it into this array. So I'm going to say, here's our array. First one goes in. It's not in here at all. We've reached the end, and so 5 goes in here. 8 is going to come in here. It's not smaller than 5, so it continues on, but there is no other one. So 8 comes in here as well. Then I want 12 will come in here. Not smaller than this, not smaller than this. It's going in. I kind of want to make this a 7, just to test. 7 comes in here, not smaller than this, is smaller than this, so this becomes a 7. That's kind of what I want to do, is swap that position if I find it smaller than that. And I kind of wonder, I don't think reduce is the easiest to sort of like go in here right away. I wonder if I can undo. Yes. I'm actually going to start over here a little bit, and I'm going to use comments to sort of figure out what I want to do. So I'm going to say, okay, to begin with, maybe I'll just take over this comment. To begin with, I want to create a new array. So initialize new array with first 2 numbers from given array. Okay, so then we're going to loop through the rest of the 2 numbers. So loop through the rest of the numbers, and if the current number is smaller than, so if it's smaller than either, well, so I guess I want to loop through the this array too, don't I? Now, I don't have to. I could just create these instead of an array here. It might be easier because I don't have to do a full loop through this as well. I could initialize 2 variables to hold the first 2 numbers. Then loop through the rest of the numbers. If the current number is smaller than well, at any the first number, swap. Swap it. Otherwise, we're not going to do anything, but we do want to check and not be an else if, and say if the current number is smaller than the second number. We also want to swap it. And then we're going to return the sum. So at the very end, way back here, we're going to say return the sum. Okay, so let's try this and see if our logic is correct here. So initialize two variables to hold the first two numbers. I'm going to be recreating these, so let's just do let and well, we can have like num1. I'll just do smallest equals, and they're going to be the first one, so numbers of 0. And then let second smallest equals numbers 1. So we're making an assumption here, but that's fine because the next thing we're going to do is loop through the rest of these numbers and then actually correct our assumptions here. So loop through the rest of the numbers. So I'm going to do a for loop because we want to start not at position 0, 1, 2. So let I equals 2, I is less than numbers dot length I plus plus, and can I easily move these? I can. Nice. Okay, so if the current number is smaller than the first number, so if the current number, so that's going to be numbers, so, and I kind of like here saying const current equals numbers of I. So that gives us the current number, and then we can also immediately check if the current is less than or equal to, so I don't really care if it's, I don't need to do the swap if it's equal to that, it's tied. So if it's less than or equal to smallest, then I want to swap it. Well, so I don't actually have to create the brackets for this. It's just going to be a single line. And I don't really need to swap it. I need to replace it. So smallest is going to become equal to current. So I'm going to say replace it. And that's what I'm going to say here is just place it as well. Okay, so now we're going to do the exact same thing here. If current is less than or equal to second smallest, well, second smallest is going to become equal to current. Okay, so we have that. At the very end, we now have smallest and second smallest. We're going to return smallest plus, it's the sum, right? Yes. Second smallest. All right, so let's first go through this in our minds really quickly. So we have this one's pretty easy. Oh, this is also easy, and this one has the smallest one down here. So 3 and 7 immediately go in. So this is going to become 3. This is going to become 7. Sorry, 87. 87 come in here. We're going to loop through starting I equals 2. So 0, 1, 2. 45 is I. So we're at 45 down here. That's what our current is going to become. If the current is less than the smallest, 47 is not smaller than 3. We don't do anything. If the current is less than or equal to second smallest, which is 87, it is. So we're going to now say second smallest equals current. So this is now 45. And we're going to now continue on. I is now, current is now going to become 12. 12 is not less than 3, but it is less than 45. So this becomes 12. Move on, 7, so then it should be 10. All right. whenever doing interviews and whiteboarding challenges and things like that, I always try to, like, for these type of challenges, get myself into the habit of running through it or desk checking it myself before hitting the run sample tests, just to make sure that, like, I don't have any major logic problems as far as I know. Now, of course, I could have a problem that I'm not thinking about, but that's what this is for. So our sample tests, well, I just failed. Passed 2, failed 3, errors 1, sum should be 6. So what happened? Will you give me what it did? Sum should be 6, instead got 4. So this one failed. So let's try to figure out what happened here, because we're not really getting any information. So we started with 15 and 28. So 15, 28, and I begins as 2, so 0, 1, 2, that'd be this 4. So current equals numbers 4, so that current becomes 4. Is current less than or equal to smallest, which is 15? It is. So this becomes 4. Now it also asks here, and this is a problem now. If I do this swap, I need to stop. Like, I can't check the second smallest again, because this is going to become 4 as well, which is that's not what I want. Now I could do, this should be an else if, shouldn't it? Because if it's not smaller than that, maybe it's smaller than this. So else if, oops, I did Command S as just sort of a habit. Okay, should be 6, instead got 30. All right, so what else did we do wrong? Now we're way off, because if we got 30, that would potentially be 28 plus 2. Okay, so let's do this again. So 15 and 28, we have begin with 4. 4 checks, are you less than or equal to smallest? If you are, smallest becomes this, so this becomes 4. Now we're doing an else if. We pass this. I kind of wanted to just move this up here now. Then move on to the next one. I becomes the next one. The 2 comes in. So I kind of am seeing the problem right here. So 2 comes in and says, are you less than 4? And the answer is yes, you are. So it gets replaced with 2. The 28 should not be there. The 28 should now be 4 and 2, but it's not. It remains the same. So, like, it was a bit, this algorithm is a bit too naive. So we can't just plainly swap numbers. What we really want to do is keep one of these as the smallest and check the second smallest. That way we can, like, well, there's a lot of different ways we could do this, I guess. If we have the smallest here, if we replace this, like, if we're going to replace this one, let's replace this one, which means maybe we can actually use these words as having actual meaning. Now another potential thing is I could actually just replace the array, and loop through and do that. I think that might be easier to sort of pivot away from actually just initializing these and just go through and say, okay, let's keep on trying this for a little bit more. All right, so we have smallest and second smallest. We're going to set these to the initial ones. So in this case, it's going to be 15 and 28. Now we're going to come in and we're going to see 4, and we want to say which one is the largest of these two. Well, in this case, it just happens to me that second smallest is the largest of the two. Now maybe what I really want to do is start with smallest, is just like initialize this off and make sure that smallest and second smallest are appropriately set up as actually smallest and second smallest. So we take in these numbers, we check if the first number, if 0, so let's try this. If numbers of 0 is less than numbers of 1. Okay, so if the first number is less than the second number, then the first number should go into smallest, and the other way around. So I'm gonna put this here. You let me tab like that? Perfect. Now we have an else, which is the exact opposite, where we take this and we just put it in there. The tabbing got all screwed up. Okay, so let smallest is really going to be numbers 1, and this is going to be number 0. So this now gives us and makes sure that we're going to begin. Now the problem here is we have let smallest inside of a block, so we're going to lose smallest and second smallest. So I kind of want to come up here and just say let smallest, let second smallest. Then we don't have to have these lets anymore. Okay, so that now assigns the appropriate amount here. Now coming through into here, we can now loop through, and I'm thinking we check the second smallest. If you're not smaller than that, there's no reason to check the other one. So we begin right with const current, and I'm going to remove these comments as they'll like quickly change. These are my initial logic as through it, so I don't need a comment telling me I'm looping through. It's obvious what I'm doing. Okay, so we're going to grab this. What we really want to do here, and I'm going to rewrite this logic. I don't want to take away the for loop block end. Okay, so we're in the for loop. We want to check if the current number, so if the current number is less than the second smallest. Now, if it is less than the second smallest, then I want to replace, then I want to also check. Because if it is less than the second smallest, I need to now check if the current is also less than smallest. So if the current is less than the smallest, then I'm going to replace the smallest. So smallest is going to become equal to current. Now, otherwise, I'm going to replace and say second smallest is going to become equal to current. Now, if current is not less than second smallest, we can break right away, but there's no reason to because we're already at the end of this for loop. So let's try this here. So we have the 1528. This was the one we ran into problems. We start, I'm not going to have it here. I'm going to put them at the top up here. Okay, so 15, 28. 15, is 15 less than 28? It is. So smallest becomes 15. Second smallest becomes 28. Then current becomes 4. 4 is going to come in and say, hey, 4, are you less than the second smallest, 28? You are. Are you also now less than the smallest, 15? You are. Smallest becomes current. So that's now 4. All right. I sort of can see that this is going to be a problem now. I do have one more thing that I can do right here to fix this problem that we're about to have. So 2 comes in, says, hey, are you less than second smallest? Yes, you are. Are you less than this? Yes. Same problem, but now we're in a slightly better position because we can say, okay, if we replace if smallest becomes this, I'm going to want to put brackets around this because I want to do another thing. Hey, I didn't want you to do that. I wanted to tab you in. I wanted to say, okay, if smallest become current, before I do that, we're going to put into second smallest, set that to smallest. Now smallest can become current, and we should be good. So let's try this now. Back it up. We're at 15 and 28. So 4 comes in, it takes over this position. 2 comes in, says, hey, are you smaller than 28? You are. Are you smaller than 4? You are. Second smallest equals smallest. This becomes 4. Smallest becomes 2. That should work. Let's give it a try. All right, passed all the tests, so I'm going to remove these comments here. And is there anything else that I want to do to sort of, well, I'm going to attempt. Run on all of these. All right, passed 110 tests, including the random tests. Perfect. Okay, so is there anything that I want to refactor with this? This block of code seems kind of nasty right here. I could replace this with a ternary. So I could say let smallest equals, and it's gonna be the check the check here, right? We're gonna say numbers of 0 is less than numbers of 1. So if numbers of 0 is less than numbers of 1, we want the smallest. So we want to return numbers of 0 from this ternary. Otherwise, numbers of 1. And then we want this thing to be exactly the opposite. So if I copy this, place it in here, if number of, well, actually, we want, if numbers of 0 is less than numbers of 1, we want to return numbers of 1, or numbers of 0. So that allows us to remove this big block of code. So what does this mean? Numbers of 0. Well, numbers of 0 is 15. Looking at this test again. Numbers of 1 is 28. Is 15 less than 28? True, so return numbers of 0, which is 15 that goes into smallest. Otherwise, else return numbers of 1, which is 28. And then the opposite true. So second smallest is, hey, is numbers of 0 less than numbers of 1, which is the same thing here. If so, return numbers of 1, 28. Otherwise, this one. So it's a sort of nice way of us not having to do that previous sort of if-else like giant block of 4 lines or so, not counting the brackets. So that makes it a little bit smaller here. We do loop through, we do want to start at 2, which is why we're not beginning with like a reduce or a for each. And we're getting the current. We could replace this and just do numbers of I, but I kind of like the way it looks. Current is less than, so this is a little bit of nasty logic here. It's because I have this else. Because I'm saying, okay, I want to make sure, well, if you're not, if current is less than smallest, now I could break this out and not have it be nested. So I could try this in a different way here. I'm going to bring this down into one level, and I'm going to say, okay, if the current is greater than or equal to the second smallest, I want to continue. So continue is basically saying move on to the next item in the loop. This round through, like this run through is done. But if you're not, then we want to check this here. And this is going to make it a little tiny bit more readable where we're going to do the swaps. So I don't need that. Of course, we're returning the sum here. Let's try this. Let's run our sample tests again. Everything is looking good. We'll attempt. Everything is good. And I'm going to submit this as our final. I guess it takes a while. Man, this does take a while. And looks like I've completed my first kata. Everybody else has their solutions down here. Looks like numbers equals numbers. Okay, so they're using sort. But the thing, this numbers equal is not necessary because sort is affecting the original array. And I didn't want to do that, although that's certainly possible. Looks like everybody's using sort though. Oh, this one didn't. This is interesting. Are they, yeah, this is still JavaScript, max safe integers. They're setting it to very high. And then they're beginning at they're beginning at 0. All right, well, end result is we have done the first of our katas, and I think if we go to our homepage, it shows that, well, I guess it doesn't show like whatever. Oh, 4, I've got 4 points. Well, I hope that you enjoy this and this provides some kind of help. I'm not going to be cutting any problems or anything else I run into in these katas. It's more of, hey, I'm just going to be working on this and we'll see how it goes. And anyways, thanks for watching, and I'll see you next time.